So last week, a junior developer actually used an AI coding assistant to write like 10,000 lines of Python.
Oh, wow. That is a lot for one sitting.
Right. They did it in a single afternoon. And the syntax was, well, I mean, it was completely flawless.
I'm guessing it deployed without a single error then.
Yep. Zero errors. Deployed perfectly. And then it completely permanently corrupted their company's entire legacy database.
Yeah, because, I mean, the AI just did exactly what it was asked to do.
Right, Dave?
It didn't actually understand the business context of the data it was touching. It just executed.
And that right there is it's the terrifying but also kind of exhilarating paradox you're facing right now if you are diving into programming.
Yeah, it really is a wild time.
Because you have these tools, ChatGPT, GitHub Copilot, Claude, and they can instantly just output entire architectures for you.
Right, the days of just agonizing over a misplaced bracket or memorizing those arcane library imports, that's effectively over.
But the flip side to that is, if a machine can do all the typing, your job description as a developer just underwent this radical permanent mutation.
It did. Because the foundational skill, it's no longer translation, right? It's judgment,
Judgment.
which is a pretty jarring shift for anyone who basically spent the last decade believing that software engineering was primarily about, you know, mastering syntax.
Which perfectly brings us to the mission for today's deep dive. We are looking at a really thought-provoking piece by technical solutions architect Mark Hazelton.
It's a great read.
It's called Learning Python in the Post-Copilot World. And we're going to deconstruct his framework for how you actually learn to engineer software when an AI is perfectly willing to just do all the heavy lifting for you.
Right, because how do you build a mental model of a system when you aren't the one physically typing the code?
So Hazelton tackles this by looking at what we've actually lost and gained. And he draws this fascinating parallel to his early career.
Yeah, back in the EDS Systems Engineering Development Program, they relied heavily on this concept called golden code.
Right. And my understanding of golden code in those legacy enterprise environments is that it was basically like battle-tested, heavily peer-reviewed boilerplate.
Exactly. You didn't reinvent the wheel.
You took the golden code, which you already knew was secure and performant, and you just adapted it to your specific module.
That's essentially it, yeah. The prevailing philosophy was, junior developers shouldn't be cowboys.
Right, no rogue coding.
Exactly. If a senior architect had already solved a concurrency issue or a database connection pool perfectly, your job wasn't to write new syntax.
You just had to identify that the pattern applied to your problem.
Yes. Implement it and verify the integration. That was it.
So I can see how it's really tempting to look at GitHub Copilot and think, great, I have an infinite repository of golden code right inside my editor.
Oh, yeah. Very tempting. But that is actually a massive trap.
Because Copilot isn't giving you golden code, it's giving you statistically probable code.
And that is the critical distinction here. Golden code was deterministic, right? It went through rigorous human QA.
Whereas large language models...
Right, by their very architecture, they are just probabilistic token predictors.
Right.
When Copilot generates a function for you, it hasn't verified that the logic is sound for your specific edge cases. It's literally just predicting the sequence of characters that most frequently follows your prompt.
So it's kind of like trying to navigate this complex legal negotiation with a hyper-fast translator.
Who also happens to be a compulsive people pleaser.
Yes. Oh, that's exactly it. The AI doesn't want to tell you, hey, your prompt is vague and this architectural approach is flawed.
No, it just wants to give you something that looks like Python, so you'll hit accept and be happy.
Right. If you mumble something vague about, like, merging two data sets, it will write a perfect script that just effortlessly drops half your null values without even warning you.
Because that's what a lot of bad tutorials on GitHub do.
Wow. Okay, so that forces the developer to completely change their sequence of operations then.
It absolutely does. Historically, a beginner would open a blank file and immediately start trying to write Python.
Just jump right in.
Right. But Hazelton argues that if you do that today, you've already lost control of the software. You cannot start with the language.
So where do you start?
You have to start with a micro-specification.
Okay, unpack that a bit.
Basically, you write out the logic in plain language pseudocode, essentially before the AI is even allowed to see the prompt.
Right, and he illustrates this with a really seemingly simple scenario in the source material.
The temperature converter.
Yeah.
Yeah.
Imagine an exchange student from Taiwan living in the U.S. They see a weather forecast for 86 degrees Fahrenheit, but their internal context for temperature is entirely Celsius.
Oh, yes. The
Yeah.
quintessential computer science 101 exercise.
Exactly. Now, if you just tab over to your AI assistant and type, write a Python script to convert Fahrenheit to Celsius, it'll do it instantly.
Oh, sure. In a millisecond.
But Hazelton argues that is an incredibly dangerous way to learn and honestly a terrible prompt.
It's terrible because you are offloading the architectural decisions to an algorithm that has literally zero context for your end user.
Right. You haven't specified the input method.
You haven't specified the data type or the precision of the output.
And when you give an LLM a vague prompt like that, it just hallucinates the requirements to fill the void.
Exactly. So it might build this hugely complex command line interface when you just wanted a simple script.
Or it might output a float with like 15 decimal places that completely ruins the readability of your UI.
Precisely. So to retain control, Hazelton insists on defining that microspecification.
Step by step.
Right. Step 1, prompt the user for a numeric Fahrenheit temperature. Step 2, apply the conversion formula.
Okay.
Step 3, round the result to exactly 1 decimal place. And Step 4, display the formatted string.
And here is the piece of his framework that really struck me, actually.
Oh.
He emphasizes that you must define the expected output manually, in your own head, before generating the code. You have to know that if the user inputs 86, the output must be exactly 30.0.
Because that 30.0 isn't just an example.
Yeah.
You know, it's your anchor to reality.
Right.
If the AI generates the script, you run it with 86 and it outputs 29.8, or it drops the decimal entirely, you have immediate concrete evidence of a hallucination.
Let me challenge this workflow for just a second here.
Sure, go for it.
If I am an engineer trying to move fast, which, let's be real, is the whole value proposition of AI, and I have to spend 10 minutes writing a meticulous micro-specification for a script that the AI could draft in a millisecond.
Aren't you destroying your own productivity?
Yeah, why not just let Copilot take its best guess, run it, and then I'll just fix the formatting if it looks weird?
Well, because you're assuming the errors will be visible.
Oh.
In a simple temperature converter, sure, you might spot a missing decimal.
Yeah.
But what happens when that script is calculating financial yield curves?
Right.
Or adjusting radiation doses in a medical device?
Wow, okay. That's terrifying.
A program can run flawlessly, throw zero syntax errors, look structurally beautiful, and execute just catastrophic logic.
Because the AI optimized for a successful compilation, not for truth.
Exactly. The ROI of an AI assistant isn't in how fast it types. It's in how much debugging time it saves you later.
That makes total sense.
If you let the AI guess the formatting and the logic, you literally have no baseline. You're just auditing the AI's homework based on vibes.
Based on vibes, that is so true and so dangerous.
Right. Hazelton's pseudocode approach keeps the problem domain strictly separated from the implementation details.
And that distinction is huge. The logic of converting temperature or, sorting a database, that exists independently of Python or C++ or Rust.
Exactly. Once you have an unshakable grasp on the logic, you can swap the languages out like drill bits.
And this shifts the beginner's focus from memorization to interrogation. You don't need to memorize the exact syntax of Python's input function on day one.
Right. But when the AI generates it, you need the analytical skill to look at the block of code and verify it.
Did it ask for the input? Did it apply the math? Did it handle the rounding?
Exactly. Which means we eventually have to prove the code actually does what we interrogated it to do.
Because even with a perfect microspecification, the LLM might hallucinate some bizarre library dependency.
Oh, absolutely. So we need a mechanism to bind this generated code to reality.
And that mechanism is automated testing.
Yes. Hazelton takes the core math of the temperature converter and isolates it into its own function.
So it's decoupled from the user input.
Right. And once it's decoupled, you can subject it to Python's Unitas framework.
He specifically points to assertal most equal, which I thought was a really great technical detail.
Yeah.
Because anyone who has dealt with floating point math and programming knows that computers are just surprisingly bad at simple decimals.
Oh, notoriously bad. You might expect 30.0, and processor spits out 30.000000004.
Right. So that's a perfect example of why you can't just eyeball the output.
Exactly. Assertal must equal programmatically guarantees that the math falls within an acceptable tolerance.
You feed the function 86, you assert it equals 30.0.
You feed it 32, you assert it equals 0.0.
But the crucial constraint here, and honestly this feels like the golden rule of the post-Copilot era, is that the AI can write the implementation, but the human must write the tests.
Absolutely. If you ask the AI to write the
Oh.
tests for the code it just wrote, you have created a self-fulfilling prophecy.
It's grading its own homework.
Exactly. The LLM will just write tests that conform to its own flawed logic. It will always pass its own audit.
The expected values must remain entirely under human jurisdiction.
Yes. So we have our baseline. We've tested the expected inputs. The math works.
Okay, so now we have to behave like a real user.
Right. What happens when our exchange student accidentally bumps the keyboard and types the word hello instead of the number 86?
The Python interpreter hits a fatal exception.
Right, you get a value error. Because the underlying C code doesn't know how to execute floating point math on alphabetical characters.
And the entire program just crashes.
Boom, done.
And, most beginners would look at that red text in the terminal and think, oh no, I failed. Or worse, they'd think the AI wrote bad code.
But it's neither. Hazelton points out that this crash is actually just evidence of an incomplete specification.
Because we never told the AI what to do in a hostile environment.
Exactly.
Yeah.
We defined the happy path, but we completely ignored the reality of unpredictable user behavior.
Which is the reality of literally all production software.
Always. And this is where the learning becomes organic. The crash creates a genuine, immediate need to understand error handling.
You aren't just reading a dry textbook chapter on Python's try except blocks because, a syllabus told you to.
Right. You are looking at a broken system that desperately needs a structural reinforcement to survive contact with a real human user.
It's like stress testing a physical structure. I mean, you can build a bridge, roll a compact car over it, and call it a success.
Sure.
But to actually understand the engineering limits, you have to hit that bridge with simulated hurricane winds and a fleet of oversized trucks.
I love that analogy. And when the concrete cracks, you don't just patch it blindly. You analyze the structural failure.
Which actually brings up a really interesting pedagogical dilemma here.
Oh.
If I find that crack-like, if my program crashes on the word hello, I can just copy that error trace, paste it back into ChatGPT and say, hey, fix this.
You could.
And it will instantly wrap the input in a try except block and stop the crash. So why shouldn't I do that?
Hazelton gives a massive warning against doing exactly that.
Really?
Yes.
Yeah.
If you let the AI fix the error autonomously, you bypass the entire cognitive process required to build a mental model of the software.
You're offloading the struggle.
Yes. Neurologically, learning requires resistance.
It requires that friction.
Exactly. It requires the myelination of pathways in your brain that only happens when you grapple with a concept. Hazelton actually calls this maintaining productive friction.
Productive friction. I like that.
So when the program crashes, you don't ask the AI to write the patch. You paste the error and you ask, explain why this crash occurred, but do not provide the code to fix it.
That constraint, do not provide the code, is brilliant.
It's essential. It forces the LLM back into the role of a tutor rather than an autonomous agent.
So it explains the concept of a value error and the theory of exception handling. But you, as the developer, have to actually synthesize that theory and apply it.
To your specific microspecification.
Right.
If you offshore the struggle to the AI every single time, your mental model of the architecture remains entirely hollow.
And then when you eventually hit a complex multi-system bug that exceeds the AI's context window,
You will be completely paralyzed.
this implies a pretty massive shift in what we actually value in software engineers, doesn't it?
It really does.
If my daily workflow is just writing plain language specifications, designing hostile test cases, and reading AI explanations of architecture, I'm operating almost entirely at the conceptual level. It makes you wonder if deep knowledge of core computer science principles even matters anymore. Can I just be a pure idea person and let the machine handle all the implementation?
See, that is the most dangerous illusion in the industry right now.
Really?
Oh, absolutely. Beginners assume AI eliminates the need for foundational concepts. It doesn't.
It just eliminates the need to memorize syntax.
Exactly.
Yeah.
You still absolutely must understand what a variable scope is, how control flow dictates logic, why a recursive function might cause a stack overflow.
Right, or how different data structures manage memory.
Because if you don't understand the concept of a dictionary versus a list, you won't even have the vocabulary to ask the AI to structure your data efficiently.
You won't know what you don't know.
Precisely. And Hazelton gives a phenomenal example of this using Pandas, which is the ubiquitous data manipulation library in Python.
Well, Pandas, yeah.
Let's say you're analyzing a massive data set for a project, and the data is messy. There are missing values everywhere.
Pretty standard.
Right. So you ask your AI assistant for a script to clean the data. And the AI, drawing on millions of GitHub repos, suggests implementing df.drop.na.
Which just violently deletes any row that contains a missing value.
Yes, and to the AI, this is a highly statistically probable solution. It resolves the immediate issue of null values, the code executes cleanly, and it returns a beautifully tidy data frame.
But the AI has no idea why you are analyzing that data in the first place.
Exactly. What if this data set is from a clinical medical trial?
Oh, wow.
And what if those missing values represent patients who dropped out of the study because the side effects of the medication were too severe?
Then the missing data is the signal.
Yes. By blindly accepting the AI's syntactically perfect suggestion, you didn't just clean the data, you completely invalidated the scientific integrity of the entire trial.
The code ran perfectly, but the business logic was catastrophically destroyed.
Which proves that the AI cannot evaluate context. Copilot wrote it, describes a tool interaction. It is not an engineering decision.
The AI optimized for a syntax error-free runtime.
But you, the human domain expert, are the one making the engineering decision to accept that implementation into your system.
The liability rests entirely with you.
100%.
That reframes the entire profession. It suggests that moving forward, we aren't really coders anymore. We are domain experts and system auditors.
I think that's a very accurate way to look at it.
Which leads to a pretty wild thought, actually. If the core mechanic of the job is now defining the problem, outlining expected outputs, and verifying the context of AI-generated solutions,
Yeah.
does that mean the total beginner on day one and the 10-year senior staff engineer are actually doing the exact same job now, just at different scales?
Structurally, yes.
Yeah.
The mechanics of the workflow have completely converged.
Really?
Yeah. I mean, the beginner working on a simple terminal script and the senior architect deploying microservices to AWS, they are both putting judgment before syntax.
They're both defining tight requirements, writing adversarial tests.
And letting language models handle the boilerplate implementation.
So the only difference is, like, the depth of their paranoia.
Huh. That's a great way to phrase it. Yes. The senior developer just has a much deeper library of historical pain to draw from.
They've seen things break in worse ways.
Exactly. They know exactly which edge cases to anticipate. They know how to spot subtle security flaws in the AI's suggestions.
And they understand the system-wide implications of a seemingly harmless function.
Right. But the fundamental loop, specify, generate, interrogate, test, that loop is identical.
Wow. So for you listening, if you have been sitting on the sidelines wanting to build software, that convergence is incredibly empowering.
It really is the best time to start.
The historical gatekeepers of software engineering, the rote memorization, the hours lost to a missing semicolon, the deeply unintuitive environment setups, they're dissolving.
You can spin up an environment and have a working prototype in minutes.
You get to bypass the tedious translation phase and operate as an architect right from day one.
You do. But with that architectural power comes architectural responsibility.
Right. You can no longer hide behind the excuse that you couldn't get the code to compile.
If your software fails now, it's not a failure of syntax. It's a failure of logic.
You traded memorization for rigorous judgment. So to synthesize everything Hazelton maps out here, learning to engineer software in a post-Copilot world means the prompt is not your starting line.
No, definitely not.
Your starting line is a meticulous micro-specification and clearly defined expected outputs. You write the tests.
And you maintain strict human jurisdiction over what correct actually means.
Right. You actively try to destroy your own software with unpredictable inputs. And when you succeed in breaking it, you use AI not as an autonomous mechanic to patch the hole, but as a tutor.
To explain the structural flaw, maintaining that crucial productive friction.
It is a complete reinvention of the learning curve.
It is. Which leaves us with a fairly profound philosophical question to consider, I think.
Oh, lay it on us.
If large language models continue to scale, and the actual typing of executable code becomes entirely abstracted away from the human experience, is the discipline of software engineering destined to look less and less like traditional computer science?
Wow. What does it become then?
Well, will it instead evolve to resemble pure philosophy or even formal logic, where the only limiting factor to what we can build is how precisely and rigorously we can articulate our desires?
Man, that really makes you evaluate your own communication skills.
Right.
We started this deep dive talking about the paralysis of entering a field where the rules just changed overnight, but the machines are doing the typing now and the syntax barrier is gone.
It's just you and your ideas.
You are the one calling the shots, with more leverage than any generation of developers before you. You just have to know with absolute precision what you actually want to say.